Hello guys, we will continue our activity regarding the appliance protector circuit. We were already through installing the power supply circuit here on the breadboard. What is next is the 555 timer circuit. Okay, let us now start the assembly of this circuit over here on the breadboard. First of all, we will install the IC here. Okay, this is the number 1, 2, 3, 4, 5, 6, 7, 8. Okay, let us install over here and let us ready the terminals of this output line here. This is now the negative side over here, negative side, and connect it here. The blue color line is the negative side. Okay, then the red color is the positive side. This is now actually the output line, and we have already measured the voltage over here, which is 12 volts. Okay, let us insert it here. This is the positive side, positive 12 volts, and here the negative side. Okay, we are connecting to the red color representing the positive side. Okay, over here, let us move this further to avoid intrication of the circuit. Okay, then remember that pin number 7 and pin number 1 are connected together based from this diagram. Pin number 7 and pin number 1. So we have here actually the pin number 1 is over here and the pin number 7 is over here. Okay, we will connect it together, pin number 1 and pin number 7. So to avoid confusion, let us insert it further from the IC over here. Okay, so pin number 7 here and pin number 1 are connected together based from this diagram. Also, pin number 8 and pin number 4 are connected together. So we have here the pin number 8 over here. This is pin number 8 and the pin number 4 is over here. Okay, pin number 1 and pin number 7 are connected together. Pin number 8 and pin number 4 are connected together. Then pin number 2 and pin number 6 are also connected together. So we have here the pin number 2 over here. So let us connect it here. Okay, connected to pin number 6. The pin number 6 is over here, because this is pin number 5. 1, 2, 3, 4, 5, 6. Okay. After connecting together, pin number 8 and pin number 4 are connected to the positive side. Okay, over here. We have here the positive side. Line for the positive. Then, pin number 8 and pin number 4 are connected together. So, you may connect it here, pwede. Or you may connect it here at the 8th side, the pin number 8. Because pin number 8 and pin number 4 are connected together, we will connect them to the positive side over here. Then, black color is for the, or red, black or blue for the negative. So, what is the negative here is pin number 1 connected to the ground, representing the negative side. Okay, over here, we have the number 1. Actually, pin number 1 and pin number 7 are connected together. Let us connect that one here to the negative side. That is to simplify the circuit. Let us make it sure that the positive line and the negative line of the power supply are connected correctly, and it should be first connected to the circuit. Okay, then we will install this one. Install. Okay, This is 1 mega ohm. You can change this one, no? Instead of 1 mega ohm, you can use 10 mega ohms. Okay. We'll try to use 2 mega ohms. Okay, we have here 1 mega ohm. 1 mega ohm is here. Okay. 1 mega ohm is here. By the way, it is connected to the positive side. You can directly connect it to the positive side over here. Positive side, no? Okay. Terminal of this resistor is connected to the positive side actually. Then, we will connect this capacitor. We will use 10 microfarad. 10 microfarad. Okay. 10 microfarad with a working voltage of 25 volts. Okay. It is connected over here. Let us transfer it here. To avoid confusion and integration. Then, the capacitor here, positive side, is connected to the terminal of the resistor. Let us connect it here. The positive side and the negative side. Connect it to the negative side. Okay. Okay. This terminal of the capacitor is actually connected to the ground, which is the negative side. Then, between these two components, there is a wire connected to the pin number 2 and pin number 6. Okay, you may use this green. Okay. Connect it here. Then, to pin number 2 or pin number 6, they are wired together. You can connect it here. Okay. This terminal here, this wire is already connected to pin number 2 and 6, which are shorted together, and connect it between these two components here. This one. Then, after that, we will install this component here. Okay. We'll use times 1 ohm to look for the two electrodes, because this is actually a light emitting diode that emits light. Okay. Okay. Okay, it gives light. It gives light. Meaning to say it's forward bias. This should be the anode. The black this rod is the anode. And we have here the cathode. The anode actually is connected to the positive side. Okay, we have here positive side. Okay. Okay, let us verify. Okay. Then there is a resistor. 1 kilo ohm resistor here. The colors are brown, black, red. Okay. Connected here to the anode. Then to this side here. Okay. To the positive side. Because this red color is the positive side. Okay. Then, another diode or lightning diode, which is the red color. Where is the red color here? Okay, we have here. Again, let us look for the two electrodes. Okay, good. Reverse bias, forward bias. So this is the cathode and this is the anode, the black test rod. The anode now actually is connected to the cathode of the first lightning diode. This is the green color. Okay. Let us connect it here. Okay. The anode here is connected to the cathode here. The anode here is connected to the cathode here. Then another resistor which is 1 kilo ohm. This 1 kilo ohm actually is a series dropping resistor that limits the voltage of this light emitting diode. It should be limited from 1.5 to 3.5 volts only. It should not be 12 volts because it will ruin the diode. 12 volts is too excessive for this light emitting diode. That's why there is a connected series resistor to drop the extra voltage. Okay? Then we have here the cathode side connected to the negative side over here. Okay. Okay. Then between this cathode and anode of the light emitting diodes, there is a wire connected to the pin number 3. So where is the pin number 3 here of the IC? This one here. Pin number 1, pin number 2, pin number 3, pin number 4. We can determine that this is pin number 1 because of the nuts here, over here. Nuts. No, nuts. N-O-T-C-H. So, pin number 3 is actually over here. Pin number 3 is over here. Okay. Pin number 3 connected. Pin number 3, it is connected over here. Between these two light emitting diodes. Okay? Between these two terminals here. Terminal here and terminal here, there is a wire connected to pin number 3. Okay? Then after that, how about this pin number 5? There is a capacitor here, a mylar capacitor, mylar film capacitor. It is a non-polarized capacitor, just like this metallized polyester film capacitor. It is non-polarized also. It is non-polarized. There is no negative and positive. So, it is connected to the pin number 5. Where is the pin number 5 here? Okay. We have here the pin number 5. This is pin number 5. This is pin number 7 connected to pin number pin number 8 to pin number, okay, there we have here pin number 4. Okay, then where is the capacitor? Okay, we have here. The purpose actually of this capacitor, which is connected to pin number 5, is to filter out, smooth out the voltage supplied to the circuit to avoid noise. No? The pin number 5 is over here. Pin number 5. Then connect it here. One of the terminals here of the capacitor is connected to pin number 5. The other one is connected to the ground. Okay. This is now the other terminal of the capacitor here, which is connected to the ground. Okay. Then we have here a diode again. This diode here is a voltage spike limiter or preventer. It prevents the voltage spike. Whenever there is power interruption or there is turning off of the circuit due to the burnout, usually during turn off, this coil or inductor will generate voltage during turn off. The voltage is higher. Probably it will reach to 50, more than the voltage applied to the circuit. The circuit here is actually supplied only with 12 volts. But there is a so-called counter-electromotive force caused by the magnetic induction of this coil. So, this diode is a snubber diode. Snubber. Snub is in UBVER. The induced voltage here, which is higher, around 50 to 80 volts, will be dropped by this diode to protect this IC from damage. Because this IC will be damaged without this diode. Because there is a large amount of voltage that will be fed here due to the magnetic induction during turning off. Okay? So let us connect here. Okay? Let us look for the two electrodes. Okay, forward bias. And we have here the reverse bias. So, look for the reverse bias, which is the deflecting pointer. So, this must be the anode. And this is the cathode. The cathode is connected to the positive side. Okay? So, it goes like this, class. Oh, guys. And the positive side is over here. Okay. This diode now is connected across this resistor and light emitting diode. Okay, we have here. Then, the relay switch, which is an electromechanical switch. It is not a manual switch. This switch here will be connected together, or will be turned on, caused by the magnetic field over here. Once it is turned on, this green LED will light, indicating that there is already a presence of 12 volts over here, which will provide a magnetic field across this coil. The magnetic field here will pull or magnetize the contact to turn this on. Okay? So we have actually here. It has 4 terminals because this orange and yellow is actually the coil. Then it is a single pole double throw switch. This is the center, the wafer or the pole, and we have here the contact. No? So although it has 3 terminals for the switch, but one of the terminals of the switch is not used. Only 4 terminals over here. The coil, it is non-polarized, of course. It should be connected over here. Pwede yellow dito, pwede orange din. Then across. Okay, across over here. Across this diode. Okay. Then this terminal over here is the contact. Connect it here. Then the switch is over here. The switch is over here, either of this one here. Okay. We are connecting this terminal of the relay switch to the input of the AC power line. We have here. Then, another switch here. Connect it here. Then, this is now the line. Okay? By the way, this is now the AC outlet where your electronic appliances is connected. No? AC outlet. Okay? It is actually connected to one of the terminals over here. You have here. Okay. Then, let us connect here. In such a way nga, you can connect the AC input over here. Okay. B. Let us check again whether there are no errors. Across. Then this one here. This one is connected to this power line. Then this one. Okay. AC power line is over here. This one here is over here. Okay. Then, let us try if this is operating. If there are no errors, connect. Okay. So we don't have available TV receiver here to be tested. Let us try to connect this one. Okay. This is now the outlet where your electronic appliances such as TV receiver, refrigerator, DVD player, computers, for example. Okay. Then, connect it here. Observe if there is an explosion. So, walang light. Walang light. Okay, there are errors again. So, let us try to check. Again, let us turn this on. The appliance protector by inserting the AC cord to the outlet. And observe class that the red LED is lighting. Meaning to say it is at standby position or condition. Meaning to say, the TV receiver is not operating. Now, the light transfers to green. Meaning to say, the TV receiver now is turned on. Okay, again, there is a power interruption. There is power interruption. Okay. Let us assume that there is brownout occur. Brownout. So your TV receiver is turned off. We will consider this lampshade as a TV receiver. It is turned off because it is brownout. But when the electricity is turning on, is coming back, your TV receiver is not operating. The appliance protector is at red, meaning to say standby. There is no voltage yet sent to the TV receiver. But after few seconds, the light transfers to green, meaning to say it is turning on now, the TV receiver. So that is now the operation of your appliance protector to protect your appliances from damages, because once the electricity comes back, there is a large amount of voltage there. Instead of 230 to 235 volts at the outlet, when it returns back, it will reach, there is an abrupt increase of voltage there. It will reach to 300 volts, which can usually affect the power supply circuit of your TV receiver. So there's a need of delaying the operation of TV receiver. So let us wait for several seconds. But the time for turning on is based from these two components, the resistor and the capacitor over here. So, the resistance here is 1 mega ohm and the capacitance is 10 microfarad. So, let us compute the waiting time. Okay. There is a formula here. Okay. Time is equal to R times C times 1.1. This is now a formula. The resistance, for example, 1 mega ohm times the capacitance, which is 10 microfarad, times 1.1 as a constant value. Mega is 10 raised to the power of positive 6 and micro is 10 raised to the power of negative positive 6 and negative 6. So cancel out mega, which is positive 6 or 10 raised to the power of positive 6, and micro is 10 raised to the power of negative 6. So cancel out. What remains now? 1 times 10 is 10 times 1.1 seconds. So 10 times 1.1, 1111. So that is 11 seconds. No? 1.1 times 1, 0, 1, 1. So, 11 seconds. 11 seconds. 0, 1, 1. So, the time for turning on is 11 seconds. Okay, let us try. Okay, you have to wait for several seconds. So, there is burnout. TV receiver now is turned off. After few hours or few minutes, the Solico operation is coming back. 1. Okay, let us count the seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. See? 11 seconds based from our computation. Then if you wish to increase the time, the waiting time, you can actually change the resistance or the capacitance. No? Okay, let us change this resistance here. The resistance here is 1 mega ohm. Let us try to change it to 10 mega ohms. We have available 10 mega ohms here. We will not change the resistance here. A while ago, it is 1 mega ohm and 10 microfarad. It is 10 seconds times 1.1. It is 11 seconds before the light changes to green. Now let us change this 1 mega ohm to 10 mega ohms. Okay? Or 2 mega ohms. Red, black, green. Okay? So, we have here positive side. Then, okay, change the resistance. From 1 mega ohm, we change it to 2 mega ohm. So, 2 mega times 10 microfarad, 2 mega ohms times 10 microfarad times 1.1. So, mega and micro are cancelled out. What remains now is 2 times 10 is 20 seconds times 1.1. So, 1.1 times 20 seconds over here is 0, 2, 2. So, it is 22 seconds. So, okay, let us try to turn this on. Turn it on. Okay. Assuming that the Solic operation now is coming back or comes back. Okay. Okay, let us do it again. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, okay, around 22 or 22 seconds. There's not a need of delaying the operation of your TV receiver for about 1 minute to 2 minutes. This is just an example. No?